Okay, hi, I'm Marty. I'm here to talk about Kotlin and Vyne. I'm probably going to talk too fast, so strap on in. Let's go for a ride. So Kotlin and Vyne is the name of the talk. The talk that was published on LinkedIn is building microservices that connect and adapt themselves with Kotlin and Vyne and Spring Boot. And so we just shortened that right back down to Kotlin and Vyne to keep it kind of nice and succinct. This is me. I've been a JVM guy for a very long time and have worked at a bunch of startups and have kind of like ping-ponged between startup land and big bank and consulting and big bank and startup land and big bank. And currently I'm doing a startup that's in at a big bank. I created this platform Vyne that I'm going to chat to you guys about. It's built in Kotlin. We're a tiny little company of 3 people, me and that guy and another guy who I think got lost. So that's kind of me. What are we going to talk about? First of all, I'm going to talk about what Vyne is, because has anyone heard of Vyne? Look, 5 hands went up. It's the new hotness. I'm going to talk about Kotlin and Vyne and just why it's cool, right? And then I'm going to do a deep dive into TypeAliases, which are a language feature of Kotlin. And we're going to talk a bit about some of the voodoo that we do, and specifically kind of how TypeAliases have inspired Vyne and the thing that it has become. So what is Vyne? So we are trying to come up with like this pithy little description of what Vyne does. And fundamentally we've observed that there is this rise of microservices, right? And more microservices pop up, and they are great, and we love microservices and Spring Boot and all of kind of the good stuff that comes with it. But there is this observation that as the rise of microservices come up and the size of the units get smaller and smaller and smaller, kind of microservices to lambdas, to nanoservices, to kind of an idea as a function gets deployed. The number of integration points that we have and the amount of time that we spend plumbing and connecting our stuff together has gone through the roof. And that stuff is boring, and it's not fun to do. And so we're like, let's build a company doing that. And so this is what we've got. Vyne automates service-to-service integration, specifically the connectivity between those microservices, right? And I'm not talking about kind of like service discovery. I'm talking about the actual connectivity. Like, I don't want to write some code to call your service. I don't want to embed your services code in my code, because if your service changes, now my code has to change. And so we want to automate that connectivity. But we want to just not tackle the trivial cases. So it's not kind of just like service to service. It's more sort of like service to service to service integration, where we can start looking at actually, given this estate of services that exist in your enterprise, really I just fundamentally want to go from this piece of information that I know, this thing that I know, to some other piece of information I want to find out, or something that I want to get done, right? And so sometimes that's a couple of hops, or sometimes that's kind of like 7 hops, and you don't really care, you just want to get stuff done. And so, Vyne kind of automates the service to 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 service integration. So that's the pithy title that we came up with for what Vyne does. And then we learned this cool new term of data mesh, which like the ThoughtWorks guys wrote this article about like a week ago or 2 weeks ago, and we were like reading it going, this is the business case for our product, and it was really cool. But that's fundamentally what Vyne does. It takes all of your microservices that are out there and turns them into this data mesh where you don't really need to know where the data has come from. You don't really need to know how you got it. You don't need to plumb the stuff together. It kind of just works. So I want to talk a bit about how Kotlin has inspired Vyne. I have been a stubborn Kotlin developer now for about 4 years. I picked it much like the TravelX guys. We were starting a new project, and I was working at a fintech consultancy, and I was starting it up, and I'm like, hey, Kotlin looks cool. I'm just going to start using it. And then I've kind of been bullying it into every place that I've worked ever since, where you just kind of stubbornly go, yeah, but I'm not going to write Java. I'm just going to do it in Kotlin. So Kotlin has absolutely inspired Vyne in a bunch of different ways, but most specifically in the way that TypeAliases exist and what they do. And we have TypeAliases are a beautiful feature that have kind of bled their way, not just through Vyne and not just through the Vyne code base, but sort of in all of the consulting that we do and all of the preaching that we do when we go to organizations to talk about taxonomies and how to build like smart languages across your organization. So this is a type alias, right? It It is a really simple, succinct concept, right? It is type alias, thing to other thing, right? And it's just, let's start using words that are more meaningful across our code base than string, right? Let's move away from kind of these primitives that aren't particularly meaningful to just little markers, just little breadcrumbs that we drop behind to just add a little bit of meaning and a little hint about what we as the developers or the producers of an SDK meant when we were authoring a thing, when we were creating an idea. And so, this isn't a Kotlin specific concept. These are in TypeScript. They're in Go. They're in Kotlin. They're in a bunch of different languages. They're not in Java, but it's not Kotlin specific. But the idea behind it is really cool, right? Let's just stop using strings, integers, primitives everywhere. Let's start assigning types that have meaning to us. And so if we look at this simple, innocent-looking Kotlin data class, right? Not doing any harm in the world, describing a customer where everything is a string. And so an ID is a string and an email is a string. And it's fine, there's nothing wrong with it. But then watch. Oh, magical. Now we have an ID is not just an ID, it's a customer ID. This is meaningful, right? Our functions down the bottom for finding our customers, where they used to be find with a string, find with a string for a customer ID, or find with a string for an email address. All of a sudden, we've left a little bit more information, a little bit more of a breadcrumb for the developers that are coming along around communicating the intent. And fundamentally, that is our job as developers, right? As developers, we are storytellers. We are here to tell and pass information to the next brave traveler that wanders through our function or through our class or through our interface. And we're just here to pass along information so that it becomes easy for people to consume our APIs. So from this little kind of idea where we start dropping these breadcrumbs and we say, a customer email address is a thing. It's not a string. It's an actual customer email address, and an ID is not a string. It's an ID. We're able to start kind of then using that information, these little breadcrumbs, to start teasing together ideas. And so what Vyne does is it lets us say, given this thing that I know, discover this other thing that I want to find out. And it uses those breadcrumbs to find a path across your organization, right? So given a customer email address, discover the first name. And that's quite simple for us. We get that, right? A customer email address, I can go and that relates to a customer, which, and a customer has a first name. And then there is a service that I can look at that says, right, well, it takes the email address in the path. And we can look at this, but by using these type aliases, we start dropping little pieces of metadata and little hints for tooling to start coming along and plugging in the gaps. So that's kind of a trivial example. That's kind of the service-to-service space. If we imagine for a second that we work not at TravelX or not at Vyne or not at some big bank or not at some hip startup, but we work at, say, Costa, and we're in the position of, we're in the team that wants to provide information about rewards off of your Costa points card, right? So given a customer email address, what are the rewards that I might be able to get my hands on? And so it's that same kind of journey, right? Customer email address to customer, to then the rewards card number is off in the marketing department, and you've got to call a service over there to look up their rewards card number with maybe the customer ID to get that back. But then to get the balance, I've got to call some other service that's transactional because that's where the current account balance lives. So I need to know what the current balance is in order to get the available rewards. But we track account balances in Costa points, and we hand out rewards with cash value, right? So a coffee's £3, a croissant's like £2, Pana raisins like $4.50 and a month on the hips. And so then we have to go off, we have to convert that account balance from Costa points into these available rewards. So there's another hop, right? So it's kind of service to service to service to service. And this is where we end up spending our time, right? From kind of plumbing, from customer email address to all these different services to resolve, to end up to get the thing that we wanted. And really all we wanted to do was say, given this thing that I know, this customer email address, discover the thing that I want to find out, which is the available rewards. And so what Vyne does, especially with Kotlin, is it lets us do exactly that, right? So this is actual kind of Vyne integration code. This is it. Given this thing that I know, here's this other thing that I want to find out. And Vyne, finds a way. It goes out and it finds a path across your services to do it. So let's take a look and see how that works. Okay. So I'm going to show you a couple of simple Spring Boot Kotlin application. So here is my customer application, Spring Boot, nice and simple. Everyone kind of, who's familiar with Spring Boot in the room? Yeah, it's bloody everywhere, isn't it? It's brilliant. Okay, and so I've got a Spring Boot app. There's nothing particularly exciting going on there. I've got some customers, and I've got this like RESTful API where I'm exposing a getter that finds the customer by their email address, right? And it takes in an email and returns a customer. And just like he said he would, he used a type alias instead of a string, right? So it doesn't just take any string, it takes a customer email address, and it gives me back a customer. And we just search through the stuff at the top. And so I can stand this up, and if we look here, in the voodoo that we've done in Vyne land, you can see that I've just gone through and I've added some annotations, because in Spring everything is an annotation. So I've just added some annotations to my type aliases to start building this kind of taxonomy of words that we can share across the organization. And one of the principles that we kind of talk about is not trying to share domain models between teams or kind of across bounded contexts. If you're a BDD, domain-driven design kind of developer, you know that a microservice is supposed to kind of encapsulate a bounded context. And so if you start to bleed your domain model across bounded context, you start to get this really awkward sharing. It goes kind of against the grain. But sharing the language, sharing the words, sharing the nouns across those bounded contexts is fine. A customer email address is a string. Cool, that makes sense, I get it. We find that if we share at that layer, at the taxonomy layer, the cost of change is much lower and the cost of interoperability is much higher. We can agree that a first name is a string, that a last name is a string, that an account balance is a big decimal, that I ran out of examples. But in banking, if you try and agree how to model a trade, or if you try to model how to a transaction, no two teams will ever agree on that, right? You will get Brexit done before you will get two teams to agree on how to model a trade. So we just have these. We don't really care about the customer. It's just made up of these words that we understand, these little microtypes that we're using type aliases for. We've just left these little breadcrumbs behind. And then if we jump over to, I've got an app where, so we've got this producer service that exposes customers via their email address. And then I've got this other service here that wants to find a customer from their email address. And it's kind of a trivial example, but it gets better. And so this is the code that we just looked at, right? So return Vyne given this thing that I know an email address, and it's a fact. Discover this customer name, right? And there's lots of different ways that we can shape this, and Kotlin as a language gives us these really kind of cool tools to make this more beautiful and to iterate on it. But fundamentally, this is the thing that I want to do, right? And so you can run this, and given an email address, you'll get back a customer name. And I'll show you a demo in a sec. But the thing that's interesting about this code when you read it is what's not there, right? So there's nowhere in there that we've said, I want to go and look up the customer service. There's no talk of an HTTP call. There's no concept of whether it's a get or a post or a delete or a whatever it might be. It doesn't know what the object is that's returned. It doesn't know that we're getting back an object, a customer, or 5 fields or 2 fields or 1 field. We don't really know anything about that, which means that when those contracts, when those services change, my code doesn't need to. I don't know whether I've taken 1 hop or 7 hops or 19 hops in order to get this done. I've just said, here's a thing that I know, here's a thing I want to find out, work it out. And it does. So if we jump into a demo of what that looks like, and I'll keep this quick. So when these services start up, just like, who's familiar with service discovery in the room? Eureka, console, those kind of concepts, yeah? So when services start up, they register to a thing, like a central directory, like a phone book that says, hey, I'm here. If someone wants to reach out and call me, this is the number they can reach me on. And Vyne just takes that concept a little bit further, where rather than services registering that they exist, they also describe what they can do. So if you've ever produced a Swagger file, you're already kind of 90% of the way there, or a WSDL or a protobuf file, or something that describes the contract of your service that you've shopped around in other teams. You're in the business of producing files that describe the capability of your service. You're just handing it over to other human beings to pull into their code to create this like nasty little compile time dependency. And we just say, well, don't do that. Let's chuck it in a repository that we'll look up on the fly. How's that? That's a Vyne guy right there. that guy. Okay, so here we go. So here's a bunch of information about my services that are running and the types that are there. And because of these little breadcrumbs that I've left behind, we can understand and we can model that, for example, a customer has a bunch of attributes. They have an email address, they have a name, right? Services call them. We can start kind of navigating what goes on in our organizations when we, and how everything hangs together. So a customer email address is a thing that can get provided. And because we've left these little breadcrumbs along in our beautiful language of Kotlin, and because we've left these little hints for the tooling, we're able to build these graphs together. And so then we can say, and I'm going to do it in the tool because it's a little bit more interesting, but I'll show you the Kotlin code. But I can say, right, given a customer email address of jimmy@demo.com, and I want to find the customer, right? And so this is the equivalent Kotlin code for what I was doing, right? We just saw it in the code before, but it's super simple. And then if I run this and the demo gods are kind, bosh, look at that. So I get back this customer, right? We get back Jimmy and that he lives in SW11. And we can start to see the service calls that have gone on and the interactions that have happened between these services without me having to write any code. And more importantly than not having to write code, because this isn't about you not writing code, it's about you not being exposed to change, right? So when the upstream consumers change their APIs, Vyne just adapts, and it does it on the fly. So a slightly more interesting example, the last one I'll do, is that one that we were talking about before, right? So given a customer, I want to find their available rewards. And here we go, so the same kind of thing, bit of magic happened, right? The code that we call, not particularly different. So given jimmy@demo.com, which is a customer email address, right? Given that fact, I want to discover some available rewards, okay? Code's largely the same. The thing that's different this time is, as we're talking about, right? There's a lot more work that has to happen in order to build that path from A to B. We have to go from Vyne to the customer service to get back the customer record. Then we have to go and look up their card number from the marketing service to get back their Costa card number. And then we need to call the rewards balance service to get back their account balance. And then finally, we need to call the shop service over here to say, what can I buy with this? But there's that wrinkle that the shop service over here speaks pounds, and this guy here speaks, the object that gets returned was in Costa points. And so Vyne works out that I can't call that service with the information that I've got. So is there a service out here that I can call to solve this problem for me? And it finds that there's a service out there that says, do you know what? I can convert things for you. I can convert currencies. So you tell me what you've got and you tell me what you want back and I'll give you back the currency. So we can start, because we've got this beautiful language now, we've got this taxonomy for describing our services that we can share across the business. We can start describing the capabilities that our services offer. And so Vyne goes, cool, well, I'm going to call to do a conversion and get it back. And we can kind of explore the services. So there's the first call to get my account balance, and I got back that Jimmy's got 2,500 points. And then we can see that Vyne went, well, the other service that I need to call needs pounds, so I'll get back. So I'll call this other service and convert it from points to pounds. It's a great exchange rate at the moment. Invest in Costa points. That's the takeaway. And so Vyne's able to kind of build those paths for you. So that's it. That's enough about Vyne. Well, let's talk about Kotlin. So TypeAlias is the thing that we love the most, right? It's the thing that has clearly driven and inspired Vyne. To get that to work, we've had to go deep into understanding how TypeAliases work and kind of shoehorn some functionality in there that wasn't supposed to be there. So Vyne is clearly driven by reflection. When those services start up, just like if you've ever produced a Swagger file from a Spring Boot service, right, we use reflection at runtime to work out what capabilities are there. So we're heavily in the kind of the reflection TypeAlias space. If you go onto the docs and you do a little bit of reading, they will say you can't really do reflection on TypeAlias. And here's the inside word, they are lying. You absolutely can. Right, so TypeAlias metadata is available at runtime. If you try and reflect on a class that has some TypeAlias, you will get some hints. So here is a data class of a person that takes a person name, like we've just seen. And if we do a little bit of reflection over this in Kotlin land, and we can say, right, look at its members and grab the first one where the name is person name, and then we look at the return type of that, we'll see that it is person name. Bosh. TypeAliases in reflection, super handy, right? So happy times, right? It's not always that good. If I instantiate a person name, I can't reflect on it. So this is just like in the JVM. If you instantiate an object that has like generics, the generics are lost. But if you stick it in a compile time dependency, you can reflect on it and get it back. Same thing. So the other problem that we have is that there is no reflection support for annotations on TypeAliases. So this little piece of code that you've just seen that drives how Vyne works doesn't work. So you can't do that. You cannot add an annotation to a type alias and reflect on it and expect to get information back at runtime. But you can do it at compile time, which is really cool. So at compile time, you can do all sorts of cool stuff with the syntax tree. Which leads us to CAPT, which is the Kotlin annotation processor thing. So annotation processors, for those who haven't played with them in kind of the JVM space, are an ability at compile time to hook into the compile cycle and start walking the syntax tree and see what the objects are that are there. So if you've ever done kind of compile time AOP, or there are some DI containers out there in the JVM that use annotation processors, it's that kind of concept, right? So rather than doing your reflection at runtime, you do it ahead of time at compile time. So we use this. And through the goodness of Maven and a chunk of XML, you can kind of wire in your annotation processor. This is open source. You can our language is called Taxi that we use for describing this stuff, so you can go and look and see how this works. But basically what you end up with is this, you have an abstract processor that you wire into the compile process, and you get given the syntax tree, and you can walk it, and you can find the find the annotations that are there. So this is super helpful. So we use this to then take all of those annotations that you popped onto your classes, and then we stash that data over in a generated class at compile time. And then when you start up your service, we go and find that magic class and pull it back in, kind of polyfill the stuff that's missing from the reflection process. And it's great, it works beautifully. So you end up with, through those annotation processes, we end up being able to kind of get the data that we want to get our hands on and have this beautiful experience. So Kotlin as a language has very much inspired the way that we think about and produce the Vyne developer experience. Kotlin, for us as developers, the APIs that we produce are the equivalent of a user experience, right? So if you've ever hung out on Dribble and looked at those beautiful UIs, the SDKs that we ship and the APIs that we produce and send around, that is the equivalent of the user experience that we can produce. So for us, when we're producing tooling for developers, the SDK that we produce, we put a lot of time and effort into thinking about what it's going to look like. And Kotlin have nailed this, right? As a UX for developers, the Kotlin language is just beautiful. So functional APIs, really kind of light, simple things like instantiating a list of a number, right? And then mapping it and doing interesting things with it. By Kotlin as a UX experience have taken away the things that I don't need to know about. So I don't need to name my parameter here, right? I can just call it. And down here when I'm trying to map, again, this information is not useful to me, so I can just ignore it with an underscore. As a developer experience, what you end up with is this beautiful, clean, concise, succinct code. Extinction functions are a big part of how we design and ship our SDKs. So extension functions are just the ability to take a bit of code and attach it to a class that someone else has produced. So you saw that just before, where we were doing taking a string and describing it as a fact. And you can just make this code available by dropping in a jar into the class path, and all of a sudden you have this ability to extend. And so that's useful for extending other people's APIs. It's also a really, really cool way of providing extensibility to your own API. So for us, when you're interacting with the Kotlin SDK, if you're interacting with protobuf methods, you're going to get a different experience than if you're interacting with JSON, because we expose different types of extension methods on our core API. It's a really nice way of exposing functionality that's meaningful to your own SDK and getting a really nice kind of clean evolution path. Rarefied generics are another really funky thing in the Kotlin ecosystem. So, working around some of the type erasure that happens in JVM land, being able to say, for us, it's given a customer discover a rewards balance, right? And you have the same thing down here, given a customer discover a rewards balance, but in Java you've got dot class, and in Kotlin you don't. Ooh. But it doesn't make a big difference in this kind of space. But then when you start to get into generics upon generics, here, discover a list of purchases. In Java, you've got to new up one of these type references, and it's just not as clean, right? It's the little things like this. The Kotlin API is just cleaner. The signal-to-noise ratio is much better. That's it. Summary. What did we talk about quickly? Vyne, really, really smart API orchestration, tiny little scrappy startup. If you are, say, for example, a company that's about to change the way that people get back their VAT at an airport and want to spend some of that new money, come and talk to us. Kotlin, APIs are a developer's UX, and Kotlin loves their developers. The user experience for Kotlin is great. The developer experience is fantastic, and it very much shapes what we think about when we produce SDKs. And TypeAliases are just pure semantic goodness. We just love them. Use them to produce code that communicates, that describes intent. Use it to produce taxonomies where you can agree on nouns across your business rather than agreeing on domain objects. Agree on language rather than contracts. Everything becomes simpler. That's it. Go there, email that guy. Have a good night.